Hello everyone, in the previous lesson we found what V and M are for any specific section on this beam, but I just made a mistake. This 2 is not here, it is here. So this is the correct one, and we can put the X inside the parentheses here, and it would look better. W over 2 Lx minus x squared. Okay, when we want the shear moment diagram, by the way, why we draw shear moment diagram? Because by doing this we see these internal loadings value all across the beam. By just looking at these two graphs, it gives us the distribution of the internal loadings, how the internal loadings change all across the beam. But before doing the shear moment diagrams, we draw the free body diagram of the beam. And this is W. It is a free body diagram, therefore there is no connections left from the support. We get rid of all the supports, and instead we show the reaction forces. Remember that the horizontal reaction force was 0, and these reactions was equal to WL over 2, This is our, and by showing this length, this is our free body diagram for the beam. Next, we start drawing shear diagram. This is x-axis representing the length of the beam. This is the y-axis representing the shear force. And in parentheses we can show the unit, but here we don't have any real number, so we don't put any unit. Okay, V and X. By using these findings, these are at the same time are the equations for, this is equation for shear force, this is equation for moment for this kind of loading. So if I want to, I can, by just looking at the equation, I can draw the shear diagram here. At point, so at the origin, x is 0. So let's clean it here. W L over 2 minus x. So at the origin, V is equal to W times L over 2. So from origin it jumps up. At the origin, V is equal to W L over 2. At one point it may be 0, we need to find it. Therefore V equals V to the 0. 0 equal to, sorry, mistake again. L over 2 minus x. So if this is equal to 0, what would be the x? That means, in other words, where is the shear force 0? It is 0 when x is equal to L over 2 from this equation. Therefore, at the mid of the beam, around here, V is 0. And when going back to the equation, as the x increases, the V value decreases, and this decrease is linear. Therefore, from the origin to the mid, the shear force will decrease linearly. It's a linear decrease. After the midpoint, this keeps decreasing, but what will it be at the end? By just substituting x with L, we obtain the value. So V here is equal to W times L over 2 minus L. That means V is equal to minus W L over 2. So at this point it is minus L over 2. So from midsection to this point, here it was V was 0, and here it is minus WL over 2, and again this decrease will be linear due to the equation. This is a linear equation. By doing this, by using just this equation, we obtain the shear diagram, but we can say that we can see at what section what the shear force is. Here the shear force is negative, for example. You can see the values at any section by using this graph. This area is positive, this area negative. Therefore, if you cut within this area, such as this, you look at the right hand surface of this section, such as this. This is your segment in 3D, and this value minus V value is shown as this. So this is your V, and the direction is this, and it is negative direction. In the previous lesson I tried to explain why we call this direction positive. From that you can understand why this direction is negative. Okay, we carry on to the moment diagram. Again, we use this equation, or this one. We know that, or I should say that, where the shear is 0, the bending moment is maximum. Therefore, for this point, which is L over 2, if we substitute it inside the moment equation, if we substitute x by L over 2, we obtain the maximum bending moment, L squared over 2 minus L squared over 4. And what does it equal to? 2 over 4. 2 over 4 minus L, okay, it is equal to plus WL squared over 8. This is the maximum value for the moment, and it is positive. At the origin, see what the moment is. If we substitute x by 0, we get 0. Therefore, the moment at point A is 0. Here, at maximum, the moment is w over L squared over 8. At the end, at the end point B, the moment is, if we substitute x by L, we get again 0. So starting from 0, coming to here, how will we come? Linearly or non-linearly? It is not linear because the equation is quadratic, is in second order, and the starting, would that be, the next question would be, will it come like this or will it come like this? Initially, there is an increase, and this increase is sudden, and the increase is getting slower to the mids, to this point, because when we enter this value for L over 2, because to the mids, this term is increasing. Therefore, the increase of the moment is less towards the mids of the beam. Therefore, the shape of the curve will be like this, not like this. Definitely not linear. From here to the end point, again, if we enter, say, something more than the half of L, this will decrease, but this decrease is less at the beginning. As we get closer to the end, the decrease will be larger. Therefore, the shape of the curve is like this. This is the end of this lesson. Thank you for listening.